over what we did last week to make sure we fully understand it. And if there's any kind of questions that you guys have got, we'll be answering those. Okay, so we're just going to go over some work that we did last week, and basically we're going to be going over just for the first 10 minutes or so. If I can actually get this board to work. Is this going to work? Yes, it's going to work. Factorizing. So we'll be going over that. Okay, so let's have a quick look at, we're not going to go through the really easy questions, we're just going to go through some of the reasonably difficult questions, and then we're going to move on. So if I wanted to factorize the first question here, if I wanted to factorize 15x squared minus 10xy, what's the common thing between these two parts of the expression? What's the common thing?
They both have x.
Okay, so what do I do then? I take the x. I take the x out. Okay, and I open a bracket.
And so also they both are in the 5 times tables.
Correct. So what is the item I put here then? So I can put a what? A 5 there? I can put a 5 there, can't I? Okay. Excellent.
And then it's gonna be 3x squared.
No, because I've already got the x outside here.
3x.
Yeah.
And only 2.
And what's the expression here?
Y.
Okay. So that's what we were doing last week. Okay. So just wanted to kind of reiterate what the rules are. Find the common factors. Okay. So find the common factors. In this case, we were saying it's a 5 because the 5 is common to the numbers 15 and 10. Okay. And then we have the common factor, which is x. Okay. And x is over here and it's over there. Okay. So just so you're clear. So these are common factors. Okay. All right. So that's the rule. And then that takes us into this particular expression of how to create the factorized expression there. All right. Let's do another one. Just so that we have a blank slate.
Okay. Next question.
Right, the next one, ladies and gentlemen. Let's take a reasonably difficult one. I don't think we did this one last week. Okay, 8a squared plus 17a to the power of 6. So, can somebody tell me what the common factors are here?
The common factor is a.
It's a, yeah. What else?
Maybe the 8 times table is going to go into 17.
Squared.
But then there's going to be 1 left over.
No.
The second common factor is 2.
Does 2 go into 17?
No, the 2 into the 6.
No. I see what you're saying. Okay, so let's just recap what we said, I think about 2 weeks ago. Okay, what does a squared actually mean? What does it mean? What does a squared actually mean? It means
times 2 plus a same times a times a times a.
So that basically a times 6 times a times a times a times a times a equals 6a. A6.
a to the power of 6. Okay. So we're adding up all these 1s, 2, 3, 4, 5, 6. That's what this means. So can you see a pattern here? This is a, remember what we said, patterns are really important. What can you see in terms of identifying the common factor? What is, can you see, what is the common factor here? So how many times does a squared go into a to the power of 6?
3.
Perfect. Does everybody understand why it's 3? Because
Yeah.
I've got one here, I've got another a squared there, and I've got another a squared there. So I don't know why I'm going at a bit of an angle, but it's probably because my... So can you see that? I've got 3a squared in my expression, in a6. So in a6, a to the power of 6, I've got 3a squares. So my other common factor, remember, we're always after the highest common factor. The common factor here is also a squared. Okay? Because a squared is common to both. It's common there, and it's common there, because I've got 3 times a squared in a to the power of 6. So I can take a squared outside and start opening the bracket. So what's the first term then if I take a squared outside?
8.
Perfect. Plus 17, because I've got no common numbers between 8 and 17. What's the next expression? A to the power of... No. So think of it this way.
Power of 3.
No. Here.
17a2.
No. Perfect. Does everybody understand why it's 4? Why is it 4? Remember.
I think it's because
I'm going to show you why. So what we've got here, I'll do it on purple. So this 4, where do we get it from? Where do we get it from? So remember, if I did an equation like this, if I did something like this, if I did let's say 6 over 4. Okay, if I did that, I could break this down into 2 times 3, correct? And also 2 times 2, correct? And what happens is, because I've got a common number, I've got 2 as common, I can cancel this out, and this becomes 3 over 2. So using those same principles, okay, I can divide to get the a4, I can divide a6 by a squared, and what happens is I lose this, and I'm left with a to the power of 1, 2, 3, 4. Okay, because what I've done is, I've just said I'm taking a squared outside, and if I do this, what does that equal to, ladies and gentlemen? That is equal to a to the power of
6.
Perfect. Okay, so all I'm doing is I'm adding these indices. Okay, I'm adding these indices. Okay, I'm just doing a plus there, because remember, I'm doing an addition, I'm doing a multiplication there, and I'm adding the indices. Okay, but so when I take the common factor out, the common factor is a squared. I need to take the a squared outside. I've got it here. So therefore, internally, inside the bracket, I've got to have a4, a to the power of 4. Okay, so that's reason why we have this particular type of setup in terms of working out the common factors. All right, we always work out the highest common factor. So maybe I should just put highest here. Okay, so this is the highest. Okay, we always choose this one there. Okay, let's do another question, because I'm along this line, so I'll make sure you understand this, because this is going to be really important for probably the one you've been looking for, which is how to solve these kind of equations. Okay, so we want to get onto that. So let's do another one. And And again, I don't think this is something we've done last week, but it's important we do these kind of complicated ones. So I've got 12 p squared plus 15, and I've got p to the power of 5, okay, and I've got q to the power of 3. Right, so highest common factor. We want to have a go at this. What's the highest? So what's
3?
Sorry?
3?
Good. So the number 3 is good. That's a number because 3 is common to both 15 and to 12. Okay?
5.
No, 5 is not going to be a
P
Squared.
squared. I think you've got this. Does everybody understand why we got p squared as the highest common factor? Why is that? Remember the reason, the question.
Because p squared goes into p. Because
Perfect.
p squared goes into the other indices.
That's right. It's the other expression. So we have, you know, as we said, p squared is equal to p times p. By the way, the dot here means multiply. So if you don't want to do lots of little dots, lots of multiplications, that's what it means.
Sir?
Yeah?
Don't you have to have an operation between p5 and q3?
So why is a p a dot? Can it be times 2?
Let's take one question at a time. So the first question, go for it, Sang. You were saying?
Why isn't there any operation between p5 and q3?
Define operation. What do you mean, operation?
It's 12p squared add 15p over 5, and then you've got just q3. Don't you have to have an operation between the two
no.
expressions?
No, necessarily, because remember, p and q are just unknowns. We don't know what they are, but eventually they represent something. Okay? So p might be an integer, q might be a fraction. We don't know yet. So in terms of if I understand what you mean by operation, if it's some kind of function, so whether it's a multiplication or a division or some sort of other mathematical function, we don't need to get into this yet. Okay, it might be more important when you discover what p and q are, but for the purposes of factorization, you don't need to. Okay, so all we're looking at is how can I simplify this? Okay, that's all I'm looking at. So if I work out the highest common factors, I can start simplifying things. So I hope that explains something. So I think we don't need to jump that gun just yet. Because they're unknowns, we don't need to know that yet. Okay? So we don't worry about that just yet.
Okay.
So you're right. So we've got 1
P
squared.
times p is 1 and p times p is 2, and then
Yeah. So you're just adding up the indices over here. Okay, 1, 2, 3, 4, 5. So what this shows, I've got p cubed left over. Okay. So I'm going to factorize this now for you guys. Let's factorize this, and this is going to be a nice one. So we know the first number outside the bracket is going to be a 3. Okay. And we know the next one is going to be a p squared. Okay. So inside the bracket, ladies and gentlemen, what am I going to have? What's the number?
12.
No.
4.
Perfect. Who shouted at 4? Perfect.
Me.
Okay, that's Leanne. I think it is, isn't it? Who shouted it out? It's a 4. Because 3 times 4, 3p squared times 4 gives me 12p squared. Okay? There's a plus. Yes.
5.
Yes. Sorry? Yes, absolutely.
5.
Yeah. And what's the next expression? What's the next expression?
3. 3.
5q3.
P cubed. Perfect. Okay? P
Then
cubed.
Q. That's it.
And then q to the power of cubed. Okay?